In this video, I am going to solve a problem that is the kth largest element in an array. So the problem statement given is given an integer array nums and an integer k, and we have to return the kth largest element in an array. Now note that it is the kth largest element in the sorted array and not the kth distinct element. So the example we can see here is this particular example is having all the different elements, and it is the k is given as equal to 2. So we have to find the second largest. It is simply we can say that the 5 is the second largest element here. Now in the another example, there are some of the elements and also having some of the duplicates. And this is the point it is talking about, that we have to return the kth largest element, which is we see in the sorted order, not the kth distinct element. So instead of k equal to 4, let's say we consider k equal to 3, then third largest element will be, this is the first largest, 6, 5 is the second largest, and again this particular duplicate 5 will be the third largest. So that's the point it is talking about, that we have to see in the sorted order and then simply return the kth largest element. It should not be the distinct element. Now coming to the code part, the final approach of this particular problem, I would like to firstly discuss my thought process, that how I will solve this particular problem. So here we are given with this particular problem, that is the kth largest element, and here I have taken the array. This is the array from the first example I have taken as the input array. And now firstly let's talk about the simplest approach which we can use to solve this particular problem. So the simple approach or the brute force approach I can talk about, let's say this is the brute force approach. So here I have been given with the array, and if I have given with this k equal to 2, it means I have to find the second largest element out of this. So we can simply see that the second largest element is this 5 here. First maximum is 6, second maximum is 5. Now how we can get this particular element? If we try to sort this array out, let's sort this particular array, and after sorting, how will it look like? Here we can sort in any of the form. We can sort in the ascending order, or we can also sort in the descending order. If we sort in the ascending order, then we can see that whatever the n minus kth index is there, the kth largest element will be present there. But here I have sorted this particular array in descending order, and we can see that this 5 is the second largest element here, which is present at the index 1. This is the index where the second largest element is present. And if we take any of the example, if we take any of the array, and if we see that whatever the k value is given, our kth largest element will be present at k minus 1 index. So simply what we can say is, we can firstly sort the array in descending order in this case, and after sorting this particular array in descending order, we can simply return nums of whatever the array we are given with, nums of k minus 1 index. That will be our result. So this is the simple brute force approach. So we need not to do anything, we just have to sort this array in descending order and then return nums of k minus 1. And now we see the time complexity of this particular approach. So time complexity will be n log n. Now why n log n? Because we are using the sorting. We have sorted this particular array, so that so it is taking the n log n time. And if we see the space complexity, so space complexity will be obviously constant, because we have not used any of the extra space. We have sorted this array in place. Now, but the problem with this approach is that it is taking n log n time, and even if this particular array size will become larger, then in that case, simply in order to return that particular kth largest element for that particular one index, we are sorting the entire array. So this is the problem, and that's why we cannot say that this is that much efficient approach. So now what we can do to more optimize, or we can say to have some better approach to solve this problem. So what I will do, I will simply take the same example, the same array which I have taken in the first approach. So here this is the array which is given in the example. Now what I can do here, see, we have to find the kth largest element. So what we can think of, that firstly we can find the first maximum, then after we can find the second maximum, then we can find third maximum, and if this repetition can be done for the kth number of times, then obviously we will come up with a kth largest element or the kth maximum. So what can be the intuition? So this is the particular intuition which we can have, that we will run a loop. We will simply run a loop for k times, and every time we will find a maximum element, and then mark that element by int min. See, whenever we find a particular element, let's say we are doing this particular thing for k times, and if we found a particular element in one pass, let's say, then whatever the element we have found, that maximum element, then we will have to mark that element by something, so that when we go in the next pass, that same element should not be considered as the maximum. And that's how when we complete the entire number of k times, this when we have the final maximum, that will be the maximum which was the kth maximum element. So this is how we are going to make this particular approach, and let's try to code this thing, and then we will come up with the what is the complexity it is taking. So here we are going to run a particular loop for k times. So I equal to 0, I less than k, and here I plus plus. So this is for k times, this loop is running, and every time I will be finding the maximum. So what I will have to do, I will have to maintain a maximum variable, let's say. So int current max equal to int min, and I will run a loop for int j equal to 0, j less than n, j plus plus, sorry, j plus plus, and inside this I will check that if my nums of j is greater than the current max or not. And if I found that my current element is greater than the current max, then what I will do, I will update my current max with that nums of j. But one thing I have to do, as I have already told, that whenever we go in the next pass, we do not want the same maximum element. What we will do, we will save this particular index wherever we have found the current maximum. We will save this index in a variable. This is the j index. Now after finding this particular maximum for this particular pass, we will go in the nums array inside that particular max index, inside that particular index which we have saved, and we will mark that particular element as int min, so that when we go in the next pass, then we will not find the same maximum element. And this is how when we complete the entire number of k times, then we will get the current max, which will be the kth maximum. So at the end we will come here and simply return this current maximum. But before that, we will also have to check this particular thing. We have declared this inside the loop, so we cannot access when we are returning this. We will have to initialize it outside of the loop, and also I have not initialized this max index variable. So I will initialize it with -1. Now let's try to run this code. So it is asking me the size, so I will give the size as 3. And what is the example we have taken here? Example is 321564. 321564, and we are asking for which k equal to 2. So for the second largest element, so it will give me 5. That's the output of this code. Now let's see the time complexity of this. So time complexity, we are running this particular loop for k times, and for every time we are also finding the maximum element. So what will be the time complexity? Time complexity will be kn. So time complexity is going to be big O of kn, and if we see the space complexity, so space complexity is constant only. We are not using any extra space. But the problem here is that this kn time complexity will be increased to n square in worst case, if this particular value of k becomes equal to n. It means whatever the size of array is there, if we have to find the kth largest element which is equal to the size of this particular array, it means whatever the value of k is equal to the n. In that case, it will become to in worst case it will become big O of n square. So this is the problem with this particular approach. Now we can also use another approach in order to make it more optimized, also more with more speed we can solve this particular problem. So min heap we can use. Now the concept is that there are two things. One is the heap sort and second is like this min heap and max heap. So what we do is in the heap sort we try to we just sort the entire array, whatever the all number of elements are present in the array. So we do not have to do that particular thing. We have to find the kth largest element. So min heap and max heap, these are the concepts which we use here. And here in the min heap, what it will do, it will maintain the k number of largest elements, means whatever the k largest elements are there in the array present. What it will do, it will maintain the k largest elements. And let's say this particular array, simply I am taking the same example. A minute. This is the array which we are going to take as an example again. So what will the min heap do? It will firstly maintain this particular k largest elements out of this array. And what it will do, whenever the new element comes and if it sees that the size of the min heap is going beyond k, then in that case it will remove the topmost element which is presented in the min heap, because that topmost element is the smallest element of all those elements. So every time when the heap size grows to and goes beyond to k, it will remove that smallest element from the heap. And this is how, when all the number of elements are visited from this array, then whatever the final min heap is made, out of that whatever is the topmost element, that will be my kth largest element. How? Because that min heap is maintaining the k largest elements. So whatever is the smallest element out of those k largest elements will be the kth largest element. So this is the all about the intuition behind this particular approach. Now let's try to code this in the platform. So what we will do is we will firstly have this size of nums in this end, and see, firstly we will have to create this particular min heap. So to create the min heap, we will use the priority queue, and in this there will be some of the parameters like int, vector int, and greater int. This is how the min heap is created. Now what are these parameters? The int is basically saying that we are storing the integer type of values, and vector int is a type of container which is storing these values, and greater int is a comparator which is used to tell that we are using this particular min heap in which the smallest element will be at the top of the heap. It means at the root node. So this is all about it. And now what we will do is we will go and we will just traverse this entire array int I equal to 0, y less than n, I plus plus, and while traversing I will simply push these elements. Min heap dot push nums of I will simply push these elements in this heap, and after pushing elements I will also check if this min heap size is going beyond k. If this min heap size is going beyond k, then what will I have to do? I will simply have to pop that particular topmost element which is present, because that is the smallest element present. So min heap dot pop. I will remove that particular element from there, and at the end, when I will be done with all this particular after visiting all the elements in the array and after pushing elements one by one and also checking the size, then I will simply return min heap dot top. So this is how I will be working with this approach. Let's try to run this code. So yes, it is accepted, and let's try to submit this. So yes, it is submitted, but I think we can have some more better approach in the same code itself, because it is taking more number of push and pop operations, because we are doing this particular thing simultaneously. We are also traversing the entire array one by one and also simultaneously checking if the size is growing beyond k. So what we can do to minimize these operations, I can remove this particular thing, and what we can do is we can simply push the first starting k elements in this min heap. So from 0 to k minus 1 it will take, that is first starting k elements. So I will push these elements firstly in this min heap dot push in this nums of I. I have pushed all those elements, starting key elements in this. Now what I will do is I will another run. I will run another loop int I equal to 0, I less than. Now see, sorry. Now till starting elements I have already pushed the elements. Now I will start from key. This is still key minus 1. I will start now from k and go till n, and this is I plus plus. Okay. Now what I will do, see, I will now, whatever the elements are left, now I am checking those. Now which of the elements I will be pushing in this min heap. See, if the element is lesser than the element which is already present at the top in the min heap, then what will be the problem? That the min heap will not be changed. It will remain same only, because whatever the elements are we are pushing in this, those if that element is also, whatever the element we are pushing, if that element is also smaller than this particular element, then that's no point of pushing this particular element, because after heapification it will be removed from the heap, so heap will not be changed. So we have to simply check if this nums of pi is greater than the min heap dot top element, and if this particular element is greater than that, then only we will push this element in this, so that whatever the element is already present at the top, that will be the smallest of all, and it will be removed from the heap, and new element will be entered in the heap after heapification. And after this, simply after heapification will be done. So this is what we have to do. So if this element is greater, then we will simply, what we have to do, firstly we will have to pop that element in heap dot pop whatever the element is already present, and then we will have to push this element, new element which we have. So this is the simple approach which we have to follow, and simply at the end we will return this min heap dot top. This is all about. But so in this case, what we are able to see, that we have only pushed the starting key elements in this, and after that we are running another loop for the rest of the elements, and if we have put a condition that if that element is greater than the top, then only we will pop that initial element and then push this one, and if it is not, then we will move to the another element. So this is how we are able to use the minimum push and pop operations. And now if we run this particular code, then maybe works more fine than the previous code. So yes, now it is somewhat greater than the previous, somewhat good than the previous code. But yes, we can also use another approaches than this particular approach in order to solve in more better time complexity, like big O of n. So let's see this time complexity of this particular code. See, and remember previous code which we have written is, and that we have run the loop for a particular means full for the entire size of the array, that is still n, and inside this we are performing the push and pop operations which are taking the log k time. So in that case we can see that the time complexity for this approach is going to be n log k. This is the time it is taking, and if we see the if we see the space complexity, so it is taking k because of the min heap which is maintaining the k number of elements, k largest elements. And also in this particular approach where we have minimized the push and pop operations, so because this particular loop is running for k times, and inside this push and pop operations are done, that is in the log k time, so we can see the time complexity to be k log k for this approach, that is big O of k log k. And if we see the second loop, so in this it is running for n from k to from k to size of the array, it means n minus k. So here big O of n minus k, and again log k because of the push and pop operations are there inside. So if we see the overall time complexity of this approach, so the overall time complexity of this approach will be, you can see that this big O of n log n, sorry, big O of n log k will be the overall average time complexity of this particular code. We see the second approach. So here the k log k for the first loop, and for the second loop it is n minus k and log k because of the push and pop operation. So overall if we see, then its average time complexity is coming out to be n log k, which is similar to this first itself. They are basically the same approaches. And yes, space complexity is again same only, that is k, was maintain the key largest elements. This is all about this particular problem. We'll meet with the new problem.